Hi everyone, welcome to today's learning. Today we are going to talk about bias and variance. When we train a machine learning model, we want it to generalize well to a new data. However, sometimes our model doesn't perform as well on new data as it does on the training data. This is where bias and variance come in. In this video, we are going to talk about what is underfitting and overfitting, and what is bias and variance, and what is bias-variance trade-off. Underfitting occurs when a model is not able to make accurate predictions based on training data and hence doesn't have the capacity to generalize well on a new data. When it performs extremely well on training data but fails to perform on the same level on the validation data, then it is called overfitting. We can see from the plot where we have plotted predictor variable on x-axis and output variable on y-axis. Here we can see the straight line which is showing underfit, and the second one is optimal, and the last one is overfitting. So then what is bias and variance? Bias refers to the difference between the expected predictions of our model and the true values of the data we are trying to predict. In other words, bias measures how much our model is underfitting the data. On the other hand, variance refers to the variability of the model's predictions for a given input. High variance means that the model is overfitting the training data and may not generalize well to a new data. So how do we balance bias and variance in our model? One approach is to use a technique called regularization, which adds a penalty term to the loss function that the model is trying to optimize. This penalty term discourages the model from fitting the training data too closely, which can help reduce the variance. Another approach is to use a larger dataset or to add more features to the dataset. This helps reduce bias by giving the model more information to work with. So we can see from the table, if we have high bias, we can increase the input features and we can decrease the regularization term. And if we have high variance, we can reduce the input feature and increase the regularization term. Ultimately, the goal is to find the right balance between bias and variance for our particular problem. It is important to keep in mind that there is no one-size-fits-all solution and that the best approach will depend on the specific data and the problem at hand. The ideal ratio of bias to variance must be established. This only makes sure that we record the key patterns in our model and ignore the noise it generates. And this is called as bias-variance trade-off. And underfitting can be avoided by creating a more complex model and eliminating noise from the data and adjusting the regularization parameter. And we can avoid overfitting by adding more features, by removing irrelevant features, using regularization, and by using ensemble techniques such as boosting and bagging. That's all for today, guys. Thank you for watching the video.